Oh, you're my best friend. 11.9 Pascal's Triangle. All right, let's see what that's all about. And who's Pascal? All right, let's start off with some basic algebra. Well, not basic algebra, but algebra 2 stuff. We have x plus y to the 0 power. You should know that anything to the 0 power is what? Is 1. So anything to the 0 power, 7 to the 0 power, k to the 0 power, x plus y to the 0 power. Anything to the 0 power is just 1. What about x plus 1 to the first power? Well, anything to the first power is itself. There it is. What about x plus y squared? Here's a common mistake that a lot of people make. They just say, oh, that just means x squared plus y squared. They just distribute that squared, but that is completely wrong. So please don't do that. You actually have to write it twice in parentheses and then FOIL. First, outside, inside, last. And that's what you get. Okay, we get a quadratic. What about x plus y to the third power? You have to do it 3 times. 1, 2, 3. And then I already did this part of it, the x plus y times x plus y, and that was the answer that we got earlier. Then you have to superfoil, distribute that one in. So take the x, distribute it into all 3. Take the y, distribute it into all 3. Combine like terms, and you should get x to the third plus 3x squared y plus 3xy squared plus y to the third. All right, we're going to keep going. What about x plus y to the fourth? That's writing x plus y 4 times in parentheses and foiling. Basically using the distributive property to get that. Now, are you guys picking up some sort of pattern yet? Because the whole point of this is to look for a pattern. Let's look at the x's. Here we have x to the 4th power, and then we have x to the 3rd power, and then we have x to the 2nd power, and then we have x, and then the x is now gone. So that's a pretty clear pattern. X to the 4th, x to the 3rd, x to the 2nd. It just goes down from there. Let's look at the y's. All right, the first term has no y, and then you have y to the first, and then you have y to the second, and then you have y to the third, and then you have y to the fourth. All right, so that's also a pretty clear pattern. So as you can see, we start off with, if the problem has to the 4th power, then our first term is going to be x to the 4th power, and then from there the x's go down as the y's go up. So this one is x to the 4th, but no y. This one has x to the 3rd, but 1 y. And then this has x squared and then y squared. And then x, y to the 3rd, and then y to the 4th. So as the x's go down, the y's go up. Okay? And if you notice, this is kind of important, is the exponents will always add up to our original exponent. And if you go back one problem as at the x plus y to the 3rd, it does the same thing. X to the 3rd, x to the 2nd, x to the 1st, no x, and then we have y with nothing, y to the 1st, y to the 2nd, and y to the 3rd. All right, so that's the pattern. But your next question should be, well, what about the coefficients, the numbers in front of each of them? This one is a 1, this one is a 4, this one is a 6, 4, 1. What about those? Because they're important. How do we figure that out? Let's see. All right, so let's try to figure that out with x plus y to the fifth power. So from now, at this point, you should be able to figure out that the first term is x to the fifth with no y plus x to the fourth, and then now the y's start, y to the first, but you don't have to put 1 if you don't want to. And then x to the third, and then the y's go up, and then the pattern goes all the way down until you end up at y to the fifth. All right, but now how do I figure out the numbers, the coefficients that go in the front of each of these guys? All right, here it is. Oh, let me erase some of that. How do I get those numbers? The 5, the 10, the 10, the 5. There's got to be some sort of pattern. In fact, there is a pattern. And we're going to use Pascal's Triangle to figure out that pattern. So here I've written down all the answers that we just did. The first one was x plus y to the 0 power. And then the last one was x plus y to the fifth power. So now that we know how to get the x's and the y's, let's go ahead and figure out the coefficients. We're going to go ahead and take the 1 and put it at the very top of Pascal's triangle. There it is. Now the next answer, we have a 1 in the front and a 1 in the front. Guess where those go? A 1 here and a 1 here. The next one is a 1, 2, 1. So 1, 2, 1. Next one is 1, 3, 3, 1. So there it is, 1, 3, 3, 1. The next one is 1, 4, 6, 4, 1. I don't know why they came out of that order, but there it is. And then the next one is 1, 5, 10, 10, 5, 1. All right, so let's look. How do we keep this pattern? How is this? Well, the obvious pattern is that there's ones along the sides. So there's ones here and there's ones here, and that's going to be correct. But how are they getting all the numbers in between? Where is this 2 coming from? How do we get this 3? How do we get this 4? How do we get this 5? It looks like 2, 3, 4, 5. The next one is 6. Yeah. The next one's 7. That's correct. So it looks like that's the pattern going that way. Same pattern going on the other side. This is going to be a 6. This is going to be a 7. This is going to be an 8. How do we get the next thing? If we look at this, 1, 3, 6, 10. It looks like we're adding 2 every time. We're adding 2, and then we're adding 3, and then we're adding 4. And then the next one must be we're adding 5. 15. And that's going to be correct. So that's a lot of patterns, but I'll show you the easiest pattern to find them. And it's basically, it's still ones down the sides, but it's basically, to get to the next honeycomb, you just add these two together. 6. Add these two together. 10. The next one, add them together. 20. 15. Did I say 10? I meant 15 over here. Let me clean that up. 1, 5. I might have said 10 earlier, but it's 15. This one, add these two together. 6. and 1. And then you keep adding, like this one would be 20 and 15 is 35 goes here. So that's how you get the coefficients using Pascal's triangle. You can fill out this whole table, and you can fill it out forever, and it'll just keep going forever. But I would like for you guys to go ahead and figure out x plus y to the 12th power. It's actually the last column of the Pascal's triangle that I gave you. All right, so that's actually your homework for tonight. It's just doing x plus y to the 12th power. See if you can do it. Have fun.